Okay, here you can see again the Malthusian growth trap, the one that I sketched on the previous slide. And you can see that the food production function and the population function have different characteristics. So if we take a look at food, we can see that food production increases at diminishing rates over time. So if you, let's say, start at a time which is very low, let's say here, when you go one period to the right, then you can marginally increase food production by that upward pointing arrow. But if you do the same thing here and you go one extra period, then there's very little extra food production. So this is a perfect example for a function which is increasing at diminishing rates. And mathematically it probably reminds you already of a utility function, but it could be something also like food production is something like, I don't know, 100 times the square root of time. That would capture a function like this. So the population function, on the other hand, is increasing, but it is increasing at an increasing rate. And that is often typical for population growth rates. So if we do the same thing, we have let's say we are early in time and we go one unit to the right in time, then the increase in population is relatively modest. But if we do the same thing here, we go one to the right, then over time there is a huge increase in population. So the population trajectory is subject to, it is positive, but positive at increasing rates. Okay, and that is of course a phenomenon that we can observe in many countries, especially younger countries, developing countries, where the population is growing at an exponential rate, but economic output, like food production, is increasing at diminishing rates. Okay, so I hope that is clear. And then inevitably what needs to happen is, at some point of time, we will have a point where maybe the food production is no longer anymore sufficient in order to feed the population. And that was the concern of Sir Thomas Malthus. Okay, so I hope that is clear.